Hello dear students, welcome you all for the fourth session of Biology NEET coaching. So we were discussing the questions from the chapter Sexual Reproduction in Flowering Plants. In last three classes we discussed about 64 questions. Let us continue. Question number 65. The following figure shows LS of embryo of grass. Recognize the scutellum in this diagram. See, even in theory, this figure is most important. So they given the figure of the embryo of grass. So in the embryo of the grass, there is a single cotyledon, what we call it as scutellum. The region above the level of this cotyledon is called epicotyle and the lower one is called hypocotyle. In the epicotyle, the labeling that we have marked B is the coleoptile, a membrane that covers the shoot primordia, that is plumule, and this the labeling C is the epiblast, and D here this is the radicle, and radicle is covered by a root cap and a thin membrane called coleolysa. So there was in the following figure shows the LS of embryo of grass. Recognize the scutellum in this diagram. So A is the scutellum. So the option is A. So option is no. Option is B. So B is the option. The A is the scutellum. Next question. 66th one. Functional megaspore forms embryo sac. After how many meiotic division? After how many? Mitotic division. As we discussed in the last class, inside the nucellus, towards the micropylar end, single cell become megaspore mother cell which is diploid, and this diploid megaspore mother cell undergo meiotic division to produce 4 megaspores. Out of 4 megaspores formed, 3 will get degenerated. Only single haploid megaspore produce entire embryo sac. So that is called monosporic development. So this single megaspore, which is haploid, the free nuclear division takes place. There is a mitotic division which produces 2 nucleus, haploid nucleus. Both these haploid nucleus now move towards opposite pole. So on the second mitotic division, 4 nucleus are produced, and each of these in nucleus, haploid nucleus in each pole, completes the third mitotic division to produce 8 nucleus. So how many division took place? First results in 2 nuclei, and second mitotic division results in 4 nuclei, and the third one in 8 nuclei, because embryo sac contain 8 nuclei. So the answer is A. So 3 mitotic division produce the embryo sac. Next slide. For the formation of embryo sac, megaspore mother cell undergoes. Megaspore mother cell. So megaspore mother cell undergo 1 meiotic division to produce 4 megaspores. 3 will degenerate, and this single megaspore, just last slide we studied, undergo 3 mitotic division to produce embryo sac. So the answer is 1 mitotic and 3 meiotic division. No. 1 meiotic and 3 division. So B is the right answer. So it will show 1 meiotic and 3 mitotic divisions. Pollination can be divided into 3 types. as well known, autogamy, geltonogamy and xenogamy, depending on the type. So, by which type we decide that the pollination is autogamy, geltonogamy or xenogamy. So, there are 4 options based on the type of pollen, based on the source of pollen, type of ovum and source of ovum as well as. So, pollination is of 3 types based on source of pollen. If the pollen that shed from the anther of a flower drops on the stigma of the same flower, it is called autogamy or self-pollination. If the pollen from an anther of a flower sheds on the stigma of another flower born on the same plant, it is called geltonogamy. If the pollen from one plant sheds on the stigma of another plant belonging to same species, it is called xenogamy. So, the source of the pollen, based on that, we divide the pollination into 3 types. So, the question is like this. In a typical complete bisexual and hypogynous flower, hope you remember, you already studied in first PUC, any flower, if all the floral parts arises from the base of the ovary, that is on the thalamus, from the base of the ovary is called superior and the flower is called hypogynous flower. So, in a typical complete bisexual and hypogynous flower, the arrangement of floral whorls on the thalamus from outermost to innermost is. This is an easy question. The outermost whorl is the calyx, which contains sepal. The second whorl is called corolla. It contains petal. The third whorl is called androecium. The individual segments are called stamens. And the last whorl is called gynoecium. So, gynoecium consists of carpels. So, calyx, corolla, androecium and gynoecium. A option is the right answer. 70th one. In algae and bryophytes and bryophyte and pteridophyte, male gametes are transported by this related question we already discussed, by water. So, as bryophytes invariably needs water to complete their sexual reproduction, so bryophytes are often called amphibians of plant kingdom. The genetic mechanism. See, the question you have to understand. The genetic mechanism which prevents inbreeding. There are many mechanisms that prevents inbreeding, but the question itself is saying the genetic mechanism which prevents inbreeding is non-synchronization, self-incompatibility, unisexuality, both A. To answer is self-incompatibility. There are several plants where their flowers are modified in such a way, if the pollen of the flower shed on the stigma, because of certain genetic mechanism, these pollen will not germinate on the stigma. Thus, it prevents self-pollination, and this mechanism of outbreeding device is called self-incompatibility. Next. In case of moth and yucca, in case of moth and yucca relationship, the moth deposits the egg in. So this, in last class we already understood about this. The moth deposits its egg in the cavity of the ovary, and that cavity of the ovary is called locule. Next one. So answer is B, locule. Here again the match of following. Albuminous seed. They have given albuminous seed, non-albuminous seed in column 1. Albuminous seed, non-albuminous seed, perisperm and scutellum. So, albuminous seed. So, the seed which have retained the endosperm. That is, the embryos not consume the endosperm even after the formation of seed. That's coconut and all monocotyledons except orchids. Non-albuminous seed, of course, groundnut, all dicots, most of the dicots seeds are non-albuminous seed except castor. So orchid among monocots are non-albuminous. Among dicots, castor is albuminous. So perisperm is a ruminant of nucellus as seen in black pepper and beet. So black pepper and scutellum, it is a single cotyledon which we find in embryo of monocot, especially grass. Next one. Starting from the innermost part, the correct sequence in an ovule is, you already know. Let us go with the options. Option A, egg, nucleus. Starting from innermost part, the correct sequence of parts in the ovule. Egg, nucellus, embryo sac, integument. No. Egg is inside, of course, inside the embryo sac, inside the nucleus. So that option is not the right one. Egg, embryo sac, nucellus and integument. Embryo sac, nucellus, integument, egg, no. Egg, integument, embryo sac, nucellus, no. The option is the second one. Egg is present inside the embryo sac and embryo sac is embedded inside the nucellus towards micropylori, and this nucellus is covered by 1 or 2 layers of integuments. Next one. The transformation of ovules into seeds and ovary into fruit. So how does it proceed? So after fertilization, that is double fertilization and triple fusion, the ovary develops into fruit and ovules into seed, which takes place simultaneously. So it's simultaneously. So epicotyle has a shoot apex and few leaf primordia enclosed in a hollow foliar structure. So in monocot embryos, the epicotyle has a leaf primordia. So this primordial is enclosed in a hollow, a thin membranous cover, which we discussed in the 65th slide. So that is coleoptile. Likewise, in the monocot embryo, the radicle consists of root cap, which is covered by a thin membrane, that is called coleorhiza. So the option is coleoptile. If they are given hypocotyle, that is radical, it would be coleorhiza. Next one. A mechanism to prevent cross-pollination is protogamy, protoandry, heterostyle, clistogamy. So they are given 4 options: protogamy, protoandry, heterostyle, and clistogamy. So protogamy is the condition in flowers when female reproductive parts mature earlier than the male reproductive part. Likewise, protoandry, when male reproductive part matures before the female reproductive part. So heterostyle is one of the outbreeding device. Here, both stigma and stamen are kept far away from each other in different positions to avoid self-pollination. Clistogamy, the condition you have already seen, already know. These flowers never open until pollination is achieved. So here, the mechanism that prevents cross-pollination, that mechanism to prevent cross-pollination is clistogamy. So these flowers never open until the self-pollen grains pollinates the stigma. So the answer is clistogamy. So this, by mistake, the figure has not been mentioned. That figure is parthenocarpic fruit of strawberry. So you go through the syncarpus, fruit part. There is a last figure. There is a parthenocarpic, figure is a false fruit of strawberry. See, fruits are categorized into 2 types. those fruits which develops from the ovary after fertilization, we call them as true fruits. If the fruits develop from any other part other than the ovary, as in apple, the thalamus is the edible part, it is the fruit. So, such fruits which develop from thalamus, there is other part, is called false fruit. So, here you have to go through the diagram in the textbook, there is strawberry. Next one. Which is not true among the following statements? Pollen grains are released from anther at 2-cell stage. Yes, of course, yes. In 60% of the plants, pollen grains release at 2-cell stage. But in another 40% of the plants, pollen get released at 3-cell stage. Sporogenous cells directly behaves as megaspore mother cell. Yes. So, the sporogenous tissue become pollen mother cell in case of androecium, in case of microsporangium, and in megasporangium, so it behaves as megaspore mother cell. Megaspore divides twice to form 8 nucleate embryo sac. The last option is egg and synergids always lie near micropylarine. So, the question is, which is not true among the following? So, the C is the option. Megaspore divides twice to form an 8 nucleate embryo sac. No, the megaspore which we already studied, it divides 3 times mitotically to form embryo sac. 80th question. Statement A states that the flowers pollinated by flies and bats secrete foul odor to attract them. So this statement is the correct statement. So many of the flowers which are pollinated by flies and bats, they secrete a foul odor or a bad odor. This attracts the bats and flies towards that flower. So this evolution or adaptation is to achieve pollination. So the statement B states that honey is made up by bees by digesting the pollen collected from the flowers. No. So honeybees suck the nectar and they break down that carbohydrate by the enzymes present in nectar stomach into monosaccharide, which is sweet to taste. So that's how it happened. So statement A is correct and statement B is the wrong statement. So here the option is statement A is correct and statement B is the wrong. C is the option. Next question. Fusion of male gamete with egg in embryo sac is called. So the fusion of male gamete with egg in embryo sac is called, what do we call it as? We call it as xenogamy. We call it as xenogamy. Triple fusion occurs between. See, last question we discussed the fusion of haploid male gamete with the female gamete is called xenogamy. It is the double fertilization. Here, triple fusion occurs between. So, the second male gamete released inside the embryo sac fuses with two polar nuclei, two haploid polar nuclei present in the central cell to form triploid primary endosperm nuclei. So, this is, the options are egg and male gamete, triple fusion occur between egg and male gamete, no, male gamete and secondary nucleus, yes, the option B is the right option. Tapetum present in the microsporangia wall occur between. So this is the easiest question. Outermost layer is the epidermis. Epidermis is followed by endothecium. After endothecium, there are 1 or 2 middle layers. Next to that is the tapetum. So after tapetum, there is a microsporangium filled with sporogenous tissue. Let us check the options. Option A, epidermis and endothecium, no. Endothecium and middle layer, no. Epidermis and middle layer, no. Middle layer and sporogenous tissue, this is the right option. So D is the correct answer. Next question. Which of the following cell on division produce 2 male gamete? So as you are aware, pollen shed at 2 cells condition. inside the pollen grain, there is one large cell called tube cell or vegetative cell, and another small cell floating in the cytoplasm of the vegetative cell is the generative cell. So as the pollen tube reaches the ovary, which is initiated, the pollen tube is initiated by the vegetative cell or tube cell, followed by the generative cell. So this generative cell divides to produce two haploid male gametes. So it is produced by which of the following cell division produce the male gamete? Sorry, the figure was missing. This is the A and this is the B. So A is the generative cell and B is the tube cell. So A, that is B is the option. So next question. A typical embryo sac possess. A typical embryo sac possess egg synergids. Together they are called egg apparatus and secondary cell. No. Egg synergids, central cell and polar nuclei. A typical embryo sac possess egg is there, synergid, together they are called egg apparatus, central cell which possess two polar nuclei. No, this is also not a good right option. Still antipodal should be there. Egg, synergids, polar nuclei and antipodals. So this is the right option. So egg, synergids, polar nuclei and antipodal. But polar nuclei representing central cell. Function of guiding and attracting the pollen tube is done by. Function of guiding and attracting the pollen tube is done by, see, already we have dealt it. As soon as the pollen tube enters the ovule, through the micropyle, it enters into one of the synergid, because this synergid, this is the egg cell, these are the synergid, they contain filiform apparatus. They contain filiform apparatus. Through this, the pollen tube enters into one of the synergid. So the answer is filiform apparatus. Next question. Clistogamous flowers are. Clistogamous flower are, they have given four options. Male flower which never open. Female flower which never open. Bisexual flower which never open. Open bisexual flower which perform self-pollination in bud condition. So you are as well aware. Clistogamous are those flowers which are bisexual. Say they never open until the pollination is achieved. So in order to achieve self-pollination, they have adopted that mechanism. So it's a bisexual flower which never opens. So the option is C. Attractants and rewards are required for. So some attractants and some rewards are required for which type of pollination? Is it entomophily? Is it hydrophily? Is it for clistogamy or is it for anemophily? Entomophily is the pollination that takes place by insects. Hydrophily is the pollination that takes place by water. So anemophily, pollination by wind. Clistogamy is a adaptation of the flower to attain self-pollination. So here hydrophily and anemophily are the abiotic pollinating agents, while entomophily is the biotic pollinating agent, that is the pollination occurs through the insects, and insects are attracted. They visit the flower often to get the reward or some nectar or some pollen. So attractants and reward are required for entomophily. So 89th question. Flower which have single ovule in the ovary and packed into inflorescence are usually pollinated by. So this we have already understood. So wind pollinated, in wind pollinated plants, so the chance of pollination is mere factor, it's a chance factor. So in these plants there are varieties of adaptation. The pollen grains are very light, they are non-sticky. So in these flowers, the small and tiny flowers which their ovary contains single ovule, they are packed to form an inflorescence. In the inflorescence, there is a feathery stamen and stigma, so which are well exposed. That is feathery stigma, stamen and stigma are well exposed. So that is wind. So wind is a major abiotic pollinating agent. A dioecious flowering plant prevents both. So dioecious plant means in these plants, male flower is produced in one plant and female flower on the other plant, as seen in papaya and some date palms. So a dioecious flowering plant prevents. It prevents both autogamy and also geltonogamy. So the only pollination that occurs in dioecious plant is xenogamy. Which one of the following statement is not true? Tapetum helps in dehiscence of anther. No, tapetum nourishes the developing pollen grain. So, it is the fourth wall layer of the microsporangium. Exine of the pollen grain is made up of sporopollenin. Yes, the outer wall exine has sporopollenin deposition. Pollen grains of many species cause severe allergies. Of course, yes, especially the pollen grains of carrot grass, Parthenium. So it causes bronchitis and many allergic reactions. Stored pollen in liquid nitrogen can be used in crop breeding. Of course, yes. So pollens, like seed bank, pollen banks are there where they store the pollen grain in minus 196 degrees Celsius, and these banks are called pollen bank. So the option, the statement which is not true is the first option. This A, tapetum helps in dehiscence. So epidermis, endothecium and middle layers, they helps in dehiscence of anther, not the tapetum. Which one of the following may require pollinators but is genetically similar to autogamy? See, in autogamy, the pollen grain produced on the anther of a flower shed on the stigma of the same flower. But in geltonogamy, the pollen grain produced in the one flower shed on the stigma of another flower born on the same plant, and most of the time it needs the aid of a pollinator. It may be a biotic or abiotic pollinator. But this doesn't bring about genetic variability because both the flowers are born on the same plant. Next one. The hilum is a scar on the... See, this you have to understand. So when we take a seed, a dicot seed, a bean seed, there are three parts: seed coat, cotyledons, one or two cotyledons, but when dicot, two cotyledons, and an embryo. So when you carefully observe this seed, so there is a whitish scar here, and this represents the hilum. So, and there is a tiny aperture which is the micropyle. So the question is, the hilum is a scar. It is a scar on the seed where micropyle seed where funicle is attached. So it's option D. So the funicle or the stalk of the ovule is attached to body of the ovule, and that region is called hilum. After seed formation, hilum appears like a scar. So it's a point of attachment of funicle. So fourth